For communities in ancient Japan, the wet rice paddy was a highly engineered food engine that provided a level of caloric stability previously impossible for hunter-gatherers. In the next 6 minutes, we are going to break down the step-by-step engineering and biological science required to build and maintain your own flooded field. To begin, you'll need a few physical prerequisites: flat or terraced land, a reliable nearby water source, earthen building materials, and a batch of pre-sprouted rice seedlings. While these materials are simple to gather, turning them into a high-yield crop requires mastering a precise mechanical balance between water management and plant biology. Your first task is construction. After clearing a flat section of land, you must build low earthen perimeter walls around the field. These are known as bunds or levees. Once the perimeter is secure, you channel water from a nearby river or stream into the contained area, transforming the dry soil into a shallow, human-made wetland. This diagram illustrates the mechanical requirements. The water channel on the left brings river water in, while the bund on the right holds it at a consistent depth. On the far end, a drainage channel releases excess water, so the field never overflows. By maintaining this flood, you create a low oxygen environment in the mud. Because most competing plants cannot survive in oxygen-poor soil, the water acts as a highly effective natural weed control. By engineering this flooded barrier, you eliminate the competition, ensuring the rice has exclusive access to the sunlight and soil nutrients. Once the field is flooded, you begin planting. As seen in this panel, you take young rice seedlings, ideally with 2 to 4 green leaves, and manually transplant them into the mud in neat, organized rows. This raises a biological question. If the low oxygen mud suffocates weeds, why doesn't it also drown the rice seedlings? Rice survives this environment through a specialized internal structure called aerenchyma. If you look at this root cross-section, you can see a network of porous air spaces running through the tissue. These spaces act like internal tubes, drawing oxygen from the leaves above the waterline and transporting it directly down into the submerged roots. However, this is also your primary failure point. As this panel shows, if the soil becomes too waterlogged or the water level rises too high, the plant may not be able to pull enough oxygen for cellular respiration, leading to root stress or death. Successful farming requires maintaining a specific depth, deep enough to suppress weeds, but shallow enough to let the rice breathe. During the growing season, you must monitor the field daily. You will constantly adjust your drainage channels to keep the water at the correct shallow depth as the rice grows taller over several months. There's a modern scientific observation regarding this system. As shown here, the oxygen-poor conditions in the mud promote specific microbes that break down organic matter and release methane, a greenhouse gas, into the atmosphere. Once the grain heads are full and golden, the maintenance phase ends. You must now close the intake channel and completely drain the field of all water. With the field dry, the harvest begins. You use stone or metal sickles to cut the stalks at the base, gathering them into bundles for processing. These bundles must then be hung on wooden racks to dry completely in the sun. This drying phase is essential before the grain can be separated. Removing the water at the correct time allows the crop to transition from a living plant into a shelf-stable food source that can be kept for months. To access the food, you begin threshing. This involves using physical force, like beating the bundles against tools, to strip the edible grains from the dry stalks. You then perform winnowing. By tossing the mixture into the air, you allow the wind to blow away the light, inedible husks, or chaff, while the heavy grains fall back into your basket. Once the rice is clean, you face your final challenge: protecting the grain from ground moisture and rodents to ensure it lasts through the winter. Ancient farmers solved this with the raised wooden storehouse. By elevating the grain on thick stilts, they kept the harvest dry and out of reach from pests. This ability to store large quantities of rice is what transforms a successful harvest into a long-term, dependable food surplus. By engineering the landscape and managing the biology of the rice plant, you have successfully secured a surplus of grain that can last well beyond the harvest season. This surplus changed the trajectory of early Japanese society. Because rice could be stored and traded, villages no longer needed to move to find food. They could grow into permanent, larger communities with specialized roles for builders, artisans, and leaders. The rice paddy is more than just a farm. It is a human-engineered ecosystem that relies on a deep understanding of how water and oxygen affect plant growth. Mastering this balance provided the stability necessary for early Japanese civilization to thrive. To begin planning your own system, you can download the Water Management Guide at the link below.